Synthesis with finite automata. Today we are going to see about the finite automata synthesis. So this is Arshita. The synthesis is about constructing a system from a given specification. So we give an overview of some of the most important versions of the synthesis problem. In the first part of this chapter, we present a pure formulation of the problem proposed by Church. It has to construct a single input or output device subject to given specification. Some severe restrictions of this problem are decidable. Example, when considering only formulas of Presburger arithmetic. So here's the example of Church problem. Sometimes specifications are easier to realize than it may seem at first. Consider, for example, in infinitely many ones in the input, then finitely many ones in the output. A simple way to realize this specification is to output only zeros. With this simple example, we touch an important difficulty in this synthesis. If a specification is not sufficiently accurate, then we are very likely to get the strange solutions. So a simple way to realize this specification is to output only zeros. This makes the conclusion of the implication true independently of the input. In order to state the Church problem, it's specification formalisms. So it's where the binary relations on infinite sequences over the alphabet 0, 1 or equivalently, then sets of sequences over the alphabet. It will be convenient to use two different formalisms for describing such objects. One is a finite automata, another one is a monadic second order logic, that's nothing but MSOL. So the nodes of finite sequences over a two-letter alphabet, that is 0, 1, and each node is labeled with a letter from A. So the empty word epsilon is the root of the tree, and every word W has a left successor and the right successor. The left successor is W0 and the right successor is W1. So we need to settle on a formal language for describing specifications. In order to state the Church problem algorithmically, we need to settle on a formal language. So in the examples, the finite sequence over an alphabet A is a function. Then often we will write it as a W0, W1 and call such a sequence an infinite word. So where Wi belongs to A or its letters, to describe a solution to the Church problem, we will need to consider infinite trees. At infinite binary labeled tree over an infinite A is a function. Then the another one is a formulation of the problem. So the formulation of the Church problem is a specification, and we are going to discuss about the possible devices that we are looking for here. So here the form of devices is not restricted. This means the device can be any arbitrary function which is mentioned here. Then the relation between two sequences can be given by an MSOL formula. That's we discussed about the monadic second order logic, that is nothing but MSOL. So here also a relation between two sequences can be given by an MSOL formula. Then a specification is a relation between input and output sequences, that is a subset of 0, 1. So we have identified the sequences before itself, that is W belongs to 0, 1, which belongs to the word A. So let us recall that we have identified the sequences. W belongs to 0, 1. Then synthesis via games, the synthesis through games. So one can view a specification as a game between a device and its environment. By these perspectives, like the environment provides inputs to the device and the device gives outputs. So the winning condition is given by the specification, that's none other than the MSOL formula. So the advantage of this approach is that some automata theory permits us to greatly simplify the class of winning conditions. It is enough to consider the parity condition instead of all. We no need to consider all the MSO properties. So it's enough to consider the parity conditions alone. Then we are at the last of our slide, which is nothing but other conclusions, like other decidable cases of the decentralized control problem refer to the notion of a communication graph, where nodes are process and edges are possible communication channels between them. There is an edge between two processes if there is an action involving both of them. So the communication graph is determined by the distribution of actions over process. So here, the in the formulation of the problem, the relation between the two sequences, that's MSOL formula with the two free set variables VW. So here the specification is a relation between the input and output, which is a subset of 0 comma 1, where it will be useful in the MSOL formula. So this formula is used for to detect or predict the winning condition. So that's all for today's topic. Thank you.